Okay, first question. What happens to the cubic function? So we're given the parent function y equals x cubed. We're given the transformed function y equals negative 4x cubed plus 1. So the leading negative means what happens? Yes, perfect. X-axis reflection. Thank you, Ben. X-axis reflection. What does that leading 4 do? Stretches. Yes, it's a vertical stretch by a factor of 4. So essentially it gets like skinnier almost. And then what does that outside plus 1 do? Because that's not inside of parentheses and it's on the outside, what is that plus 1? Perfect. It's a vertical shift up 1. Okay? Any questions about number 1? Those are just some of your basic transformation rules. Okay? All right, number 2. Number 2 is a quick look and get answer. We're given a table. The table is of x and y values, ordered pairs, -3, -10, 4, 11, -6, -3, and 2, 4. We're being asked to find F inverse of 4. So remember, we've talked about inverses over the last few days. When you have an inverse function, on your inverse function, what happens to the ordered pairs? They flip-flop. So on the inverse function, we'll have -10, -3. We'll have 11, 4. We'll have -3, -6. And we'll have 4, 2. So based on this new set of ordered pairs for the inverse function, what is F inverse of 4? Remember, go to 2. You got it. Perfect. F inverse of 4 is 2. Okay? So basically, go to the y to get the x if you're just going to keep it on the table. But if you create your new set of ordered pairs, what matches with 4? 2. Okay, let me go back to 1. Tell me when you're ready. Okay, number 3. Yeah. Okay, number 3 is just asking us to find the inverse function. Okay, given 5x plus 7, find the inverse. Okay, so remember those steps from yesterday. Switch x with y. Solve for y. Subtract 7. Divide everything by 5. So our inverse function is x minus 7 over 5. Or we can write it F inverse of x equals, fix that. F inverse of x equals 1/5 x minus 7/5. Both are equivalent. Both are the inverse of 5x plus 7. Switch x with y, solve for y. Does anybody need more time on number 3? Okay. Number 4. Describe the end behavior and the zeros. Okay. So we want to write an end behavior statement, and then we want to describe the zeros of this cubic polynomial. So how do I know it's cubic? Because it has 2 turning points. And then if you have the turning points and you add 1 back, that tells you the degree. So there's 2 turning points. So it's a 3rd degree. Okay, end behavior. As x approaches positive infinity, where are your y's going? Look at the right-hand side of the graph. Positive infinity. As x is approaching negative infinity, so that's the left-hand side of the graph, where are your y's going? Negative infinity. Perfect. Okay, and then the zeros, we see that the graph intersects the x-axis at x equals -2. X equals -2 is a 0 with a multiplicity of 1. And then the other 0 is x equals +4 is a 0 with a multiplicity of 2. How do I know it's a multiplicity of 2? It bounces on the x-axis. Okay, so when you have a function that bounces on the x-axis at a given point, that is a double root or a multiplicity of 2. Anybody need number 4? There's 3, but remember, if it has a multiplicity of 2, that means essentially it's raised to the power of 2, right? And then the other one is -2. You good here? Okay, number 5. The function below has a 0 at x equals 2. What are the other zeros? Okay, we're going to use synthetic division. We're going to put 2 on the outside. Across the top, we're going to put the coefficients in descending order. Okay, and then we do the synthetic division algorithm. Drop, multiply, add, multiply, add, multiply, add. We got a 0 remainder because we used a 0. Our resulting quotient is x squared minus 4x minus 6. So to find the 2 other zeros, I'm going to use the quadratic formula because this is not factorable. Okay, so we'll use the quadratic formula to find the remaining 2 zeros. Opposite b plus or minus the square root of b squared minus 4ac all over 2a. Plug in our values. Opposite b plus or minus the square root of b squared minus 4 times 1 times -6 all over 2. Under the radical, we have 16 minus -24, which would be 16 plus 24, which is 40. 4 plus or minus the square root of 40 all over 2. The square root of 40 is not a perfect square, but we can simplify it down to the square root of 4 times the square root of 10, which would give us 4 plus or minus 2 root 10 all over 2. And then, of course, we're not done. We have to simplify one step further. And simplifying it one step further would be dividing everything by 2. Dividing by 2 here, here, and here, which gives us our 2 other zeros, which are real, but they are irrational, meaning they're a non-terminating decimal. So we have 1 0 here, and the other zeros are x equals 2 plus or minus the square root of 10. 2 plus root 10, 2 minus root 10. So this cubic polynomial passes through the x-axis at 3 real zeros. 2 plus root 10, and 2 minus root 10. How did we get the 2 other zeros? We use the quadratic formula. Okay? Anybody need more time here? All right, number 6. What is the radius of the circle given by this equation? All right, time to do a little bit of completing the square. Another option, of course, is to put it straight into Desmos and then finding the center and radius that way. But I like to show you how to do it by hand, so I'm going to show you it that way. Group your x's, group your y's, add your blanks. X squared plus 8x plus blank plus y squared minus 12y plus blank equals 29 plus 2 blanks. Group your x's, group your y's, move your constant over. When you complete the square, you do your b term divided by 2 squared. 8 divided by 2 squared, 16. Negative 12 divided by 2 squared, 36. I have to place my 16 and 36 over in these blanks. I then factor. This would factor to x plus 4 squared. This one would factor to y minus 6 squared. 29 plus 16 plus 36 is 81. I have the standard form equation of my circle, and I can see that the center, it just wants the radius? Okay, well, we'll just do both. The center is negative 4, 6, and the radius length is the square root of 81, which is 9. Another option would be stick that straight into Desmos, because every single question on next week when you take your EOC will have a little tiny calculator, which is Desmos. And you can find the center and the radius that way. Okay? All right, number 7. Ooh, this looks fun. Number 7 is a polynomial long division question. We have to set up the division problem and do it using polynomial long division. Your divisor is x squared plus 5x plus 6. Your dividend is x cubed plus 3x minus 12. No, why did I say x cubed? It's clearly x squared. Sorry. Okay. How many times does x squared go into x squared? Once. Multiply back out x squared plus 5x plus 6. Make a parentheses and subtract. These cancel. 3 minus 5 is negative 2. Negative 12 minus 6 is negative 18. That's going to serve as your remainder. Negative 2x minus 18. So our quotient would be 1 plus negative 2x minus 18 over x squared plus 5x plus 6. Now, you can see it one other way, and that's if you pull out the negative from the negative 2x minus 18, and you would say 1 minus 2x plus 18, because essentially that would be distributed into to make it negative 2x minus 18, and then over x squared plus 5x plus 6. So these are the same solutions, it's just written in two different ways. More than likely, you would see the bottom one, which just indicates that you would have needed to pull the negative out and just left it 2x plus 18. Because when the negative is distributed back in, it gives you negative 2x minus 18. What's that? Polynomials, unit 3. Yes, long division. Okay. All right, question 8. A grain silo has the shape of a right circular cylinder topped by a cone. The area of the circular base is 153.94 square feet, and the height of the cylinder is 33 feet. The cone adds an additional height of 17 feet. If a bushel of grain is 1.244 cubic feet, what is the maximum number of bushels that the silo can hold? A lot of numbers. This is a confusing problem. Let's highlight some of the things that we know. The area of the, it's not letting me highlight. I will use underline. The area of the circular base is here. The height is 33. The cone has an additional height of 17. And then it tells us what the bushel of grain is. Okay, so we need two formulas here. Your cylinder formula is pi r squared times height. Your cone formula is 1/3 pi r squared times height. We are given the area of the circular base, which is pi r squared. We're given that. We don't have to compute pi r squared. It's given to us. So we're going to take and we're going to plug in 153.94 times 33. That's the volume of the cylinder. And then we're going to do the volume of the cone, which is 1/3 times 153.94 times 17. That's your cone. We're going to add those two together. And that is the total volume of the grain silo. Once we have the total volume, we can divide it by the cubic feet of each bushel of grain, because the volume total is the total volume in cubic feet of the silo. And then we're dividing it by each singular bushel's volume. Okay, so let's go over to Desmos, calculate the volume. Okay, calculate the volume. 153.94 times, lost it, times 33. Okay, plus 1/3 times 153.94 times 17. Okay, that right there is the total volume of the silo. Okay, I'm going to put a big parentheses, around the whole thing, and I'm going to divide it by 1.244. Was that right? 1.244. So I took the volume, which is the numerator, and I divided it by each singular bushel. The maximum number of bushels of grain that the silo can hold would be 4,784. We can't round up because why? Right, there would be no space. You would be busting at the seams. So the maximum capacity is 4,784 bushels. So we took and we divided that sum by 1.244, which gave us a max of 4,784 bushels. Okay. All right, number 9. Oh, sorry. Yep, tell me when you're ready. The what? The total volume was here. Without this. Sorry, hold on. The total volume was 5,952.347. 559 or 5,952.347 divided by 1.244. Yep, we still get the same answer if you rounded to the nearest thousandths and did the division. Good? Okay, number 7. Are you just going to take a picture, or I'm posting the notes and this is being recorded. So you'll have the opportunity to go back to it. Okay? Okay, number 9. The length of an arc is 28 centimeters and the radius is 4. What is the radian measure of the central angle? Formula is arc length equals radius times theta in radians. That's how simple that formula is. Arc length equals radius times radians. 28 equals 4 times theta. Divide by 4, theta equals 7, which is 7 radians. You definitely want to know this formula here. Okay, number 10. Convert from radians to degrees. This is as simple as sticking it straight into Desmos. What do we stick into Desmos? 13 pi over 12 times 180 over pi. We go straight to Desmos. We stick it in 13 pi over 12 times 180 over pi. 195 degrees is our radian to degree conversion. Okay, 13 pi over 12 radians is equivalent to 195 degrees. Okay, we're going to move to day 5. Okay, remember we talked about doing 2 in a row so that we can have some work time for Friday. All right, number 5. Sorry, it's kind of long. All right, determine all of the features of the rational function. Horizontal asymptote, vertical asymptote, x-intercept, y-intercept, whole. First thing you always want to do is factor. Factor the top, factor the bottom. Pull out a 2 from the top. Pull out a 2 on the inside, x plus 2. At the bottom, pull out a negative 1 on the inside, x squared minus 4, which would then factor to a difference of 2 perfect squares, x plus 2, x minus 2. So we're really working with 2 parentheses x plus 2 over negative 1, x minus 2, x plus 2. I automatically see that something cancels. What cancels? X plus 2. So that means there's a hole at an x value of negative 2. So I'm going to stick that down here. So my simplified function is 2 over negative 1 parentheses x minus 2. So when I plug negative 2 back in, it would be 2 over negative 1 times negative 4, which is 4. 2 over 4 is 1/2. The degree is bigger at the bottom because it's an x over an x squared. Bobo, bigger on bottom, is y equals 0. The vertical asymptote is whatever's left in the denominator that makes the denominator 0, which would be the vertical asymptote x equals 2. The x-intercept is whatever's left in the numerator that makes the numerator 0, and there's nothing because there's a 2 left at the top. There's no way it could be 0. And the y-intercept is when you plug 0 in for x, which would be 2 over 2, which is positive 1. So the x-intercept is whatever's left in the numerator. So you look at your simplified function, which is down here in yellow. What's left in the numerator that makes the numerator 0? Can the numerator ever be 0? No. So there's no x-intercept. Okay. All right, question 2. I'm pretty sure we did this the other day. I think it was day 1, but I'm just going to run through really quick, define what each of the centers of triangles are. We did that the other day. You have it on video. You have it in your notes. You have it in your the note slides and everything. I'll do it again though. Centroid is your intersection of the medians. And remember, it follows the 2-to-1 ratio. 2/3, 1/3. The orthocenter is the intersection of the altitudes. The incenter is the intersection of the angle bisectors. It's also equidistant from the sides. And lastly, the circumcenter is the intersection of the perpendicular bisectors. And that's equidistant from the vertices. Okay, so you should have these many places in your notes, on uploaded slides, and on the video. You want to make sure you can know and recognize the centers of triangles, both pictorially and by definition. Okay, I'm going to post these, so I'm going to move just because the bell's going to go very soon at 8:25, so I just want to make sure we finish. Okay, in parallelogram, FGHI. So let me draw that. Ooh, that was a good one. FGHI. F is 2x minus 3. G is 7x minus 1.5. Find the measure of angle I. F and G are supplementary. What does that mean? Thank you, Ben. They add up to 180. 9x minus 4.5 equals 180. 9x equals 184.5. Divide by 9. I'll use the calculator. Oh, geez. and we get x equals 20.5, but it wants us to find the measure of angle I. The measure of angle I will be congruent to the measure of angle G because opposite angles are congruent. So the measure of angle I will equal 7 times 20.5 minus 1.5. And I'm just going to stick that right into Desmos, exactly the way that I see it. And I get 142 degrees. The measure of angle I is 142 degrees. Okay, number 4. Number 4 is a classic Desmos problem. I'm going to stick the left-hand side in, I'm going to stick the right-hand side in, and I'm going to find the intersection. Y equals 14 to the power of negative 2x plus 5. Y equals 199. Go to Desmos. Put those in. Negative 2x, what was it, plus 5? Y equals 199. Okay, and I'm going to zoom out and zoom back in. And my intersection is 1 point, did it tell us to round to anything? 1.497. Easy. Desmos for the win with that one. Okay, number 5. Write a polynomial equation in standard form. X equals negative 3 has a multiplicity of 2. X equals 5 has a multiplicity of 1. And x equals 2 has a multiplicity of 1. So I'm going to set it up. X plus 3 squared times x minus 5 times x minus 2. X plus 3 squared is x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. X minus 5 times x minus 2 is going to be x squared minus 7x plus 10. And then we multiply. X squared goes into everything, 6x goes into everything, and 9 goes into everything, which would give us x to the 4th minus 7x cubed plus 10x squared plus 6x cubed minus 42x squared plus 60x plus 9x squared minus 63x plus 90. Combine like terms, and our polynomial function will be x to the power of 4 minus x cubed negative 32 negative 23 negative 23x squared minus 3x plus 90. How can I check I did the multiplication correct? Is if I put my answer into Desmos, it should bounce at negative 3, and it should cross through the x-axis at 5 and at 2. So I just want to show you that really quick. Y equals x to the 4th minus x to the 3rd minus 23x squared minus 3x plus 90. Hit my home button. Okay, you can see it bounces at -3, it crosses at 2, and it crosses at 5. So yes, we did all of the math correctly. Okay, all right, question 6. Circles unit to secants. The formula to find x here would be outside times the whole equals outside times the whole. Combine like terms. Distribute. Bring 6x to the right-hand side by subtraction. Bring 81 to the left-hand side by subtraction. What is that, 27? Yeah. X equals 9, and we're done. So remember, it's outside times the whole equals outside times the whole. And that's how we got the original setup here. Okay, number 7. The density of ethyl alcohol is 0.789 grams per milliliter. What is the weight of ethyl alcohol that exactly fills a 55 milliliter container? We're going to use our density formula. D equals M over V. They give us the density, 0.789. We don't know the mass. That's what we're looking for. We know the volume is 55. We simply cross multiply here. We multiply 0.789 times 55, and we get 43.395 grams. M equals 43.395 grams. Let me make that a little darker. I'm tired. Number 8. Determine the end behavior, the zeros and the intervals of increasing and decreasing. Classic Desmos question. We stick it directly into Desmos. Y equals negative x to the power of, to the power of 3 minus 7x squared plus 5x plus 75. Okay, zoom out a little bit. Ooh, there's a nice 0 there at 3 and a -5 with a multiplicity of 2. Zoom out to kind of observe the end behavior and its intervals here. All right, so from -infinity to -5, it's decreasing. -5 to 1/3, it's increasing. 1/3 to infinity, it's decreasing. Okay, so it has zeros at x equals -5, multiplicity of 2. X equals, I already forgot the other one, 3 with a multiplicity of 1. Okay, from -infinity to -5, it's decreasing. From -5 to 1/3 or 0.3 repeating, it's increasing. And from 1/3 to positive infinity, it's back to decreasing. And then as x approaches positive infinity, y is going to negative infinity. As x approaches negative infinity, y is going to positive infinity. That's reading the left-hand side and the right-hand side. Okay, number 9, we're almost there. 9 and 10. All right, we got this. And then you'll have plenty. Tomorrow we'll go fast, and then you'll have Thursday and Friday to do reviews 4, 5, and 6. You place your pencil at 210 degrees on the unit circle. You move counterclockwise through a measure of 3 pi over 2. What is the exact value of the sine measure on which you land? Okay, you are on the unit circle. You're at 210 degrees, which is here. 0, 90, 180, 270, back to 360. Okay? You're moving 3 pi over 2, which if you convert to a degree measure, that's the same thing as 270 degrees. We need to move 270 degrees counterclockwise. So that's in this direction. Okay, so I'm going to move. Here is 60. Here is 90 more. 90 plus 60 is 150. I need to go 130 more because I need to go a total of 270. So I'm going to go 90 more. So far that's 240. And I need to move 30, which I'm going to jump right here, which is 120 degrees. Okay, so that's a jump of 30. That's weird. Why won't it let me write that? Okay, 30. 60 plus 90 plus 90 plus 30 adds up to 270. Okay, at 120 degrees, the ordered pair is negative 1/2, comma, the square root of 3 over 2. Sine is your y value, so the exact sine is the square root of 3 over 2. Okay, last question, number 10. Whew. Number 10 is the intersection of two secants. We're going to add the arcs, divide by 2, set it equal to the angle. 55 plus 5x plus 15 divided by 2 equals 60. 70 plus 5x equals, we're going to multiply by 2, so 120. Subtract 70, 5x equals 50, x equals 10. Okay, so again, I multiplied by 2 here and here to get, and combine like terms to get the value of x. Okay, that was a lot. I'm going to stop.